Alright guys, so you've been researching solutions for the past few days. So I wanted to give you a brief overview or reminder of what a solution is. And then we're going to start talking about something called concentration. So solutions are a homogeneous mixture. And notice that prefix in there, homo meaning same. So these are mixtures that are the same throughout. And we can also use this definition: a uniform mixture that may contain solids, liquids, or gases. A lot of times when we are talking about solutions, we're talking about solids dissolved in liquids or liquids dissolved in liquids, but in actuality, these can be gases dissolved in liquids, gases dissolved in gases. So right now, if you are breathing out, you are breathing out carbon dioxide into the atmosphere, which is mostly nitrogen, so that would be a gas-gas mixture. If you have had a soda recently, that soda is carbon dioxide dissolved in water, so that would be a gas-liquid mixture. So some parts that are important to understand before we move on are solutes, and that the solute gets dissolved into the solvent. And like we were talking about previously, the solute, a lot of times we think of that as being the solid, but just like I was saying, it is not necessarily the solid. It can be a gas. So again, if in a soda you are dissolving gas into the liquid water, the gas would actually be the solute. The water would be the solvent, water being the universal solvent. Now what we're really going to get into today is concentration. And there will be, we're going to talk about a lot of different ways of measuring concentration. And basically what concentration is not how much schoolwork you've been doing over the past couple of weeks, or how hard you're thinking about that schoolwork. But really, in chemistry class, it's how much solute is dissolved in the solvent. So I wanted to give you a quick kind of picture of that. So since we are currently social distancing, I did not go to Food Lion to get you any Kool-Aid to show you this with. But you can think of this with Kool-Aid. If you have really thick, syrupy, sweet Kool-Aid, that Kool-Aid would be super concentrated. This is my coffee from this morning. I had some left over. So this would be pretty concentrated coffee because I like it pretty strong. But if I take some of this water, I can dilute my coffee. So this would now be less concentrated coffee, and definitely not coffee that I want to drink, as it is now very not concentrated coffee and pretty nasty. Okay, so that's concentration. So we had more concentrated coffee before, and we have less concentrated coffee now. So we're talking about how much, again, solute is dissolved in the solvent. So before, we had a lot of coffee dissolved in the solvent water. Now we don't have as much. So the first way we're going to talk about measuring concentration go together. They are percent by mass and percent by volume. And at this point in your careers, all of you should have done percentages. And I know that we've done percentages in our class. So I want you to remember that any percent in the whole world is a part divided by the whole and multiplied by 100. So if I'm thinking about, let's say, my garden this summer, okay, I might decide or figure out how many or what percentages or what percent of my garden is going to be vegetables out of the whole thing. So I might have, let's say I might be growing 8 vegetables. I might be growing 10 flowers. And I'm not very good with fruits, so I might be growing 2 fruits. So what I'm going to do is I'm going to add those all up. I get 20 as my total plants. To find my percentage, I take my part. Remember, I wanted to find the percent of vegetables that I was growing. So I'm going to take my 8 vegetables. And I'm going to divide that by my 20 total. I'm going to multiply by 100. And I get 40%. So 40% of my garden this summer is going to be vegetables. All right. Now let's start to apply that to concentration. So again, the first 2 ways that we're going to use to measure concentration are going to be percent by mass and percent by volume. So percent by mass, if we have percent by mass, the part of what we are measuring is going to be the solute. So we're going to have the mass of the solute divided by the mass of the solution. Remembering that our solution is made up of 2 parts. It's not just the solvent. The solution also has the solute in it. And of course, we're going to multiply that by 100. Very, very similar to that, we're going to use percent by volume. Sorry, I'm getting a little messy. This is not the easiest. Okay, so just like with percent by volume, I'm going to have the volume of my solute divided by the volume of my solution. Again, with my solution, knowing that it can be made up of my solute plus my solvent. Now, when will you use percent by mass and when will you use percent by volume? Percent by volume is used in liquid solutions. Percent by mass is used when you've dissolved a solid in a liquid or even a solid solution. But mass would be used when you have a solid dissolved into your solvent. Okay, now we're going to get started on some practice problems. First one, percent by mass. I'm hoping I'm centering this correctly and you can see the whole problem. If you can't, listen along with me. Again, I'm doing my best with these new restrictions, but I think I have this about where the other one was. All right. What is the percent by mass of iced tea containing 1 gram of aspartame in 235 grams of water? So we're going to use our percent by mass formula. Remember, our percent by mass formula is the mass of the solute divided by the mass of the solution, with the understanding that this could be my solute plus my solvent. Okay, so this gives me the mass of my solute, and let's look up here. 235 grams of water. Water is my solvent. It is not the entire solution. So I'm going to need to, on this bottom part, add my 235 to my 1 gram of aspartame. So where I have percent by mass, I have my mass of my solute. I'm going to have 1 gram divided by 235 grams. That's for my water, plus my 1 gram of aspartame. If you're going straight into your calculator, make sure you put parentheses around that. Also, make sure you're putting in a plus sign right here. This is not a multiplication symbol. Since this is a total down here, our solution, solute plus solvent, there should be an addition sign, plus sign. Alright, so when I do 1 gram divided by 236 plus, or excuse me, got a little ahead of myself there, 235 plus 1, we do get 236 there on the bottom. I get before, and I didn't put to multiply by 100 up there. Alright. Before I multiply by 100, I get 0.004. Then when I multiply by 100, I get 0.42%. Okay, so that's after I multiply by 100. Alright, let's move on to another problem. Similar, but this time we're doing percent by volume. Just wrote on the wall a little bit. Get that later. This problem, I have 60 milliliters of pure acetone being mixed with 550 milliliters of water, and it wants to know what is the percent by volume of acetone. Once again, our formula, percent by volume. And the reason they're using volume in this one is because acetone is a liquid. So when we're dissolving a liquid into a liquid, we're going to use percent by volume. So our percent by volume, we're going to have our volume. I know that's annoying. Volume of the solute plus the volume of the solution multiplied by 100, being aware, once again, that this could be my solute plus my solvent. Alright, in this case, my solute is my acetone, so I'm finding the percent by volume of my acetone. I'm going to put my equal sign down a little bit further here. So I'm going to have 60 milliliters divided by 550 milliliters. Because again, water is only my solvent. I have to add it to my solute. Plus 60 milliliters. Multiplied by 100. And I do always put parentheses around that bottom part. And that's just a dot on my whiteboard. Don't worry about that. And this time I get 9.84%. Okay, last question. This one's going to be a little bit different. Wrote it on the wall again. It's a good thing I can paint over it. Alright. This question says a bottle of hydrogen peroxide is labeled at 3%. So in this case, they're giving us the percent. It says if we pour out 30 milliliters of hydrogen peroxide, what volume of that is actually hydrogen peroxide? Okay, so in this case, we're going to use our formula, percent by volume. And why am I using volume? Well, it wants to know about volume, and it's giving us 30 milliliters. All right, so percent by volume is equal to the volume of my solute divided by the volume of my solution multiplied by 100. Okay. Ooh. So, in this case, usually I like to go ahead and solve using my variables, but in this case, I'm going to actually go ahead and plug everything in. It's one of those random circumstances where I'm going to go ahead and plug everything in. So I have my percent by volume as 3%. I'm solving for the volume of my solute, so I want my volume, and hydrogen peroxide is H2O2, divided by the volume of the solution. Now, up here it gives me 30 milliliters of hydrogen peroxide. Now, that's talking about the entire solution, because it says a bottle of hydrogen peroxide is labeled, so that's talking about the entire solution. All right. So when you, just a quick guide, when you go to buy hydrogen peroxide off the shelf at a store, it generally is labeled 3%. And what happens is they take this pure hydrogen peroxide, like we're about to find the volume of, and they cut it with water. And that's where we're getting this 30 milliliters of solution. So you're going to find out how much water they're actually cutting it with, multiplied by 100. Well, how do we figure this out? First, I'm going to divide both sides by 100. And at some point, I'm probably going to have to switch whiteboards because I'm running out of room. All right, so when I do that, 3 divided by 100 is 0.03. And I am going to switch my whiteboards up. Try and make it a little easier while we do it. So when I divide both sides by 100, remember that was to get rid of us multiplying by 100. So I divided both sides by 100. So I got rid of that right here. So this is what I have now. Okay, I have 0.03 is equal to the volume of hydrogen peroxide divided by 30 milliliters of solution. Now, if I'm solving for the volume of hydrogen peroxide, I need to multiply both sides by 30 milliliters. Okay. And that will leave me with my volume of H2O. Excuse me, H2O2. All right. So 30 times 0.03 is 0.9. So only 0.9 milliliters of that entire 30 milliliter bottle that we had is actually H2O2. And that's it to our introduction to concentration. More to come.